Here we are in Chapter 4 review exercises with the answers to number 19 through 24. Number 19. A motorboat took 1 hour to make a 10-mile trip up the river, but only half an hour to come back down. What is the speed of the boat? And what is the speed of the river current? All right, so we're dealing with speeds here, and we have rate and time. So overall, we're going to be using rate times time equals distance a lot. In this case, we're going to have two equations, but we need to use as much as we can here. So if it took 1 hour to make a 10-mile trip, then up the river, up the river was 10 miles per hour. But it took a half an hour to come back down. So in that sense, let's change color here. Down, we may need to do a little figuring here. Down, we don't know its rate, but it was rate times time. Oops. Let's go back there. Rate times time, that's rate times 0.5 equals 10. If we divide both sides by 0.5, we get that the rate is 20 miles per hour. So we have these two rates. So we know that upriver, we have the boat minus the river. So the boat is working against the river and it gives you 10 miles an hour. And when the boat goes with the river, it gives you 20 miles an hour. This is how we get our two equations. We first have to do some background and get our rates going up and down the river that are total, which are then a combination of the boat plus the river and the boat minus the river. These are set up to do elimination. So we add them and we get 2b equals 30. So b is 15. So the boat is 15 miles per hour. And if we stick it in, 15 minus 5. So the river is 5 miles per hour. And that kind of makes sense. If the boat is 15 miles an hour, if it's working against a 5 mile an hour current, then it's only going 10 miles an hour. If it's working against if it's working with a 5 mile an hour current, then it's now going 20 miles an hour because the river is pushing the boat even faster. All right, let's try it the same way. Number 20, a plane took 3 hours to complete a 1,500-mile trip. So rate times 3 hours is going to give us 1,500. And some of you could do this in our head and say, oh, when it's into the wind, it's going 500 miles per hour. Okay. And coming back, it only took 2 hours. So if we do this with a different color, coming back, that means the wind is behind it. It only took 2 hours. So rate times 2 rate times 2 would be 1,500. We get the rate is 750 miles per hour. So we have two equations here that we can now use. When we're doing the plane and the wind, so when the plane is flying into the wind, they subtract and we get 500 miles per hour. And when the plane is being pushed by the wind, they add together, it's 750 miles per hour. Okay, so look, we're set up with a system of equations, two equations and two variables. So now we take and add them and we get 2p equals 1250. So that means p is 625. So the plane speed is 625 miles an hour and the wind speed is then looks like you stick that in, plane minus the wind, or plane plus the wind has to be 750, subtract 625 and you get 125. So the wind was 125 miles per hour and the plane at 625 miles per hour. And again, it kind of makes sense that if they're flying against each other, you subtract them and you get, well, he's moving 500 miles an hour, and with the wind behind him, 750. Cool. All right. Mixture problems. Let's draw this line over here and remind ourselves of what the mixture problem formulas are. We know that the volumes will add. Okay, so that's the total volume. And that the percent or the price or the whatever of 1 times the volume of 1 percent of the second, volume of the second, has to equal the percent times the volume of the total. Percent times volume, those guys will add up just like that. So number 21. That gives us, let's write it over here. Number 21 is 5 cups of what concentration? So if we put everything in that we know, P1 and P2, V1 and V2 are 5 and 17. So we know the volume total is 22. So we have the thing we don't know, the percent of 1 times 5, plus 70% times 17 has to equal 60% of 5 plus 17. So this equation right here gives us 5 plus 17 is 22. All right, so we get 5x plus 11.9 equals 0.6 times 22 is 13.2. Subtract 11.9 from both sides and we get 5x equals 1.3. So divide by 5 and divide by 5, and 1.3 divided by 5, let's bring out our trusty calculator. 1.3 divided by 5 equals 0.26. So x equals 0.26 or 26%. Great. Number 22. We have 18% and a 75% solution. How much of each? So we are actually looking for x and y here. So we need an x and a y in order to do it. So x going with that one, y going with that one, should be mixed to produce 30 gallons of 55% solution. So let's write number 22 right down here. So we know that x plus y has to add up to 30 gallons. And then we have that 0.18x plus 0.75y has to equal 0.55 times 30. So that's this equation right here, the percent times the volume, percent times the volume, percent times the volume. That's right there. And this is actually the equation of how much powder or concentration we have. So we know from this guy, we now have two equations and two variables. And you could use elimination on this and it would work. Substitution, I think, is a little bit easier, but you could do the other one if you wanted. 30 minus x goes right in there for y. So we get 0.18x plus 0.75 times 30 minus x equals 16.5, I think is what that comes out to be. Go ahead and jump that guy in, and we get 0.18x plus 0.75 times 30. Let's punch that in, make sure we get that right. 0.75 times 30, 22.5. So 22.5 minus 0.75x equals 16.5. 0.18x minus 0.75x, that is minus 0.57x equals, subtract 22.5 from both sides, and we get 6. So x is going to equal, oh, we get a negative 6, I apologize. Divide by negative 0.57, and we get 6 divided by 0.57, the negatives cancel, and we get a positive number, 10.5 gallons. Alrighty, 10.5. So notice that the 10.5 gallons, that is x, which we said x was for the 18%. So 10.5 gallons of 18% solution, and the y then is the rest of it, up to 30 gallons. So 30 minus 10.5 would be 19.5 gallons. So y has to be 19.5 gallons, and that's of the 75% solution. So about a 2-to-1 ratio there. Fascinating. Okay, so there you go. Number 22, good. 10.5 gallons and 19.5 gallons. All right, number 23. So here we have 8,000. It's split between two accounts with an annual interest yield of 4% and 8%. How much was invested in each? That means we've got two variables, an x and a y. X amount at 4%, y amount at 8%, and there was a total interest. So if we write this out, we know that x plus y has to equal $8,000. And that the interest equation, 4% of x plus 8% of y has to equal the total amount of interest, 396. Notice that this is almost the exact as that equation right up there. These two equations, in fact, we just don't know what the overall interest rate was, somewhere between 4% and 8%, but it tells us the overall interest. So it still allows us to use both equations. And just like we did in the other one, y is 8,000 minus x. So that is going to go right there. So we get 0.04x plus 0.08. 8,000 minus x equals 396. Jump that guy in. 0.04x plus 640 minus 0.08x equals 396. 0.04x minus 0.08x is negative 0.04x equals, if we subtract that over, we get negative 244. If we divide by a negative 0.04, divide by a negative 0.04, we now get that x is going to equal, better pull this guy up. And what do we get? 244 divided by 0.04, and we get 6,100. So x is going to be $6,100. And then y is going to be the rest of it, which is $1,900. Okay, excellent. Okay, number 24, the last one. Almonds sell for $3.50 a pound and peanuts sell for $2.75 a pound. How much of each should be sold to create a 15-pound mixture that sells for $3 a pound? This P is going to stand for price instead of percent, but it's really the same concept. Have almonds and peanuts. So we know that the almonds plus the peanuts have to add up to 15 pounds. And that's this first equation right there. And the next one, we know that 350 for the almonds plus 275 for the peanuts has to equal $3 for the 15 pounds total. Notice that this is, the whole mixture has to cost $45, and we need to figure out what ratio will do that. So substitution, this A is going to be 15 minus P. Oh, stick it in right there. And yeah, 3.5 times 15 minus P plus 2.75 P equals 45. So jump that guy in there, and we get 52.5 minus 3.5 P plus 2.75 P equals 45. These two go together, and we get negative 0.75 P equals, subtract that over, we get negative 7.5. All right, so divide by negative 0.75. This one's nice. We don't even need the calculator for 0.75, and we get P is 10. Wow, P is 10. So 10 pounds of peanuts, and that means the almonds have to be add up to the other 15, so it has to be 5. So 5 pounds of almonds and 10 pounds of peanuts. Excellent.